So write down the heading, factor of safety. Factor of safety. Factor of safety. Okay, FS. So write down here. There are few uncertainties related to design procedure like first, uncertainty of load. Second, uncertainty of dimensions और size, है ना. Third, uncertainty of material. Okay. So we cannot exactly predict the load, we cannot exactly manufacture the exact dimension, and we cannot have the pure material. Okay. So we use factor of safety to provide some reserve strength, to the material or member, to the member. Okay. What is the reserve strength? Reserve strength is like in your bike or car also there is some reserve condition. Okay, the before emptying the diesel tank, some diesel will be always remaining, let's say 1 liter or 1.5 liter, and here the meter will show the zero, empty. Your car tank is empty, so this is the reserve quantity, reserve volume of the diesel or fuel inside the vehicle. Okay, so here the vehicle will count 0. So this is the reserve volume or diesel. इतना बचा रहना चाहिए, because sometime you are on the highway and nearest petrol pump or diesel pump is far away. So if you are fixing distance is 300 kilometer and you are putting only fuel of 300 kilometer, you are very efficient engineer. Okay, so for that there will be always some reserve. So reserve strength means actually you can apply the applied stress less than equal to let's say for ductile material yield strength tak, but due to uncertainty of load, material and dimension, we will not go up to this. We will apply the stress lesser than this value. So our allowable stress, the designer will set, as a designer you will set the allowable or permissible stress, let's say only sigma by T by 2. Then applied stress you can applied only up to by 2. That's it. Okay. So for a factor of safety 2, there will be much more safety. Let's say you can go up to 100 megapascal, but you will be allowed only up to 50 megapascal. So maximum up to which you can go and you allowed, this difference is called your reserve strength. Okay. So here reserve strength is reserve strength is sigma strength, or you can say maximum, minus sigma allowable. Okay, that's it. Allowable. Okay, now factor of safety. So factor of safety formula will be given by what? Factor of safety formula will be equal to the maximum stress upon the working stress or applied stress. वर्किंग स्ट्रेस और अप्लाइड स्ट्रेस. अभी मैक्सिमम स्ट्रेस कौन सा होगा? मैक्सिमम स्ट्रेस विल बी लाइक सिग्मा मैक्स यू विल राइट. ओके, और यू विल राइट सिग्मा मैक्सिमम अलाउबल, or you will write sigma maximum permissible. Sigma maximum permissible divided by the sigma working, or you can say sigma applied, or you can say sigma induced. Got the point or not? Sigma induced. Okay, sir, here sigma maximum is yield strength in case of ductile material. Yeah, in case of ductile material, this sigma maximum will be sigma yt. Okay. Okay, so here you can see that factor of safety will be more than equal to 1 always. Okay, equal to 1 का तो कोई मतलब ही नहीं बनता, but so fs will be more than equal to 1 always. Higher the value of factor of safety, more safer will be the member. Yes or no? When factor of safety will be higher, more safer will be the member or element. तो फिर फैक्टर ऑफ सेफ्टी कितना रखना चाहिए? बढ़ाते जाओ इसको. यस और नो? कैन वी गो ऑन इंक्रीजिंग द फैक्टर ऑफ सेफ्टी? इट इज वेरी गुड फॉर अस. नो. व्हाई? व्हेन यू आर इंक्रीजिंग द फैक्टर ऑफ सेफ्टी, then you will increase the dimension of the member, or you will decrease the load, or you will decrease the load. Yes or no? So if load is decreased, then the process will be not efficient for us, because your machine can take only less load. And if you are increasing the dimension of the shaft or element, then more material you are using, so more cost will be there, and more weight of machine part will be there, so mileage of car will go down. Yes or no? So we cannot keep on increasing the factor of safety. So write down here, higher value of factor of safety is good, but we cannot keep on increasing the value of Fs, because to increase Fs, either increase the dimension like dia of shaft, or decrease the load, or decrease the load. Okay, in both cases, the process will be inefficient beyond a certain value, as more dia, more weight, so more cost. Again, less load, less work output, so less profit. Hence, we have to select optimum factor of safety, not maximum or minimum. Okay, so we will go for, as a good designer, good engineer, we will go for optimum value of factor of safety. Got the point or not? Optimum value of factor of safety. So few optimum value for different load and different materials I am going to give you. Okay, so that you have to write. First, no need to mug up these things. Okay, these are just for idea for you. Yield strength over working strength 1.5 to 2. Ductile material and static load. Like your structural steel and aluminum. Next, sigma U by W 3 to 5. Brittle material like cast iron. Because there is sudden and total failure, brittle failures are more risky, as more risky. So high factor of safety is applied. 1.5 to 2 for shear loads. Generally, the yield shear strength is 50% of yield tensile strength. Endurance strength 1.3 to 1.5 in case of fatigue load. Next, sigma E surface 1.8 to 2.5 in case of surface failure. For example, pitting. In bearings, cam and followers. So cam, follower and the gears, they are subjected to surface failure. So in those cases, factor of safety is little bit high because the speed of running will be very large. In case of buckling, the buckling load over applied or working load 3 to 6. Here also risk is high. So high factor of safety are used. Okay. So these are the few optimum values for different type of material and different type of loading. Okay. So up to this, it was very basic. Now we are actually entering into the subject. Actually entering into the subject.